Chapter 16, question 2 asks you to classify each of the following amino acids, glycine, T, glutamic acid, and PHE, as polar or nonpolar. So that will be our first distinction. Is it nonpolar or is it polar? Then, if it's polar, we're going to have to distinguish a couple other things. Indicate if the R group is neutral, acidic, or basic. And then indicate if each is hydrophobic or hydrophilic. So that's for both of these. Hydrophobic or hydrophilic. So, let's start with glycine, and we're going to refer to table 16.2. Now, in table 16.2, you have a list of a whole bunch of amino acids. This is table 16.2. You can recognize them as amino acids because on the left of each, in the blue boxes, on the left you have amines, so nitrogen with all single bonds. Remember that amines are bases, so if they are in water, like the amino acids are in your body, they're going to accept an H and get a plus charge. And that's why they have NH3 plus here. So that's the left side, and that's on every single one of these. That makes the amino in what makes them amino acids. Okay. Then, notice that on the right side, you have COO minus. Now that's an abbreviated form of writing COO. So notice that here the carboxylic acid has lost its hydrogen because it's an acid, and that's what acids do. They donate H pluses. So if you put a carboxylic acid in water, it'll give away the H plus, and it'll have one less H, and it'll have one less charge, so it'll have that minus charge here. So on every single one of these, you also have that carboxylic acid. Technically, when a carboxylic acid loses an H, it's called a carboxylate. Carboxylate. And so these have the amine groups and the carboxylic acid groups, or the carboxylates. And so you can recognize all of these things on this table as amino acids. And they all have that same blue box. In the blue boxes on all of these, you'll notice the blue boxes are always the same. What's different is what's in the yellow boxes. And those are called the R groups. These yellow boxes are all R groups. They are what make the amino acids different from each other. Okay. So, that difference, some of those R groups share similarities, and some of those R groups are very different. And they're classified as either nonpolar, and here they're talking about the R groups. So notice these R groups don't have nitrogens, oxygens, or fluorines in them. Here you have one nitrogen, but consider how many more carbons and hydrogens you have, so it's far outweighed and it's overall nonpolar. So those are all nonpolar, and another term for nonpolar is hydrophobic. Hydro is referring to water, and phobic, a phobia is a fear. So these R groups fear water. In other words, they won't mix with water, and that should make sense, because like dissolves like, water is polar, and these R groups are nonpolar. So they wouldn't mix with water, and they're hydrophobic. So all of that's listed on the table for these. Then, you'll see that there are polar amino acids. And in these, you have nitrogens, oxygens, or fluorines, or just underneath oxygen on the periodic table is sulfur. So those are all electronegative elements, and they will pull electrons to themselves, become slightly negative, and what they're bonded to will be slightly positive, and that makes them polar. Next to polar, another kind of way of saying that is hydrophilic. Hydro means, again, water, And phil means love. So philosophy is the love of wisdom. Philadelphia is the city of brotherly love. Philip is a guy who loves horses. And a molecule that's hydrophilic loves water. And that would make sense because water's polar, these are polar, and like dissolves like. Now, all of these are polar. Everything from that down, these are all polar. Within polar, there are two categories. There is neutral, and there is acidic, and there is basic. So we have two big categories, nonpolar at the top, polar at the bottom. Within polar, we have acidic and basic. And also note that another term for nonpolar is hydrophobic, and another term for polar is hydrophilic. So armed with that classification, let's look at these. And this is just going to be a matter of looking it up on the table. Glycine. Glycine is at the top left of this table. Notice, so the first thing we want to find out is it nonpolar or polar? Glycine is nonpolar. Next, if it's polar, we would have to say whether it's neutral, acidic, or basic, but since it's not polar, we don't have to do that. However, for both of these, we have to say whether it's hydrophobic or hydrophilic. Nonpolar is hydrophobic because water is polar and like dissolves like. So a nonpolar molecule will not dissolve in it. It will be afraid of it. It will be hydrophobic. Okay, so that's glycine. Now for this next one, they just give you a letter, a capital T. Each of these these are the main 20 amino acids in your body. There are more, but for each of these, they have a name. And the name is given at the bottom: glycine, alanine, valine, leucine, isoleucine, etc. But because that name is sometimes long, especially if you're describing a protein that has hundreds of thousands of these things, there are two ways of abbreviating the name. The first is a 3-letter abbreviation, and that's given as the first abbreviation in the parentheses. And the second, when the 3-letter abbreviation was still found to be too long, the second is a 1-letter abbreviation. So there are 3 names for each amino acid, or rather there are 3 ways of representing the name for each amino acid. There's the full name, there's the 3-letter abbreviation, and there's the 1-letter abbreviation. So they could give you any. And in the second example where they give you T, that's just the 1-letter abbreviation. So we're looking for that T, and you'll notice that that is threonine right here. It has the T there. So threonine. Now, the first thing we need to find out is it polar or nonpolar? Well, it is polar. Threonine is polar. We can see that from the table. Okay, if it's polar, we have to find out whether it's neutral, acidic, or basic. Remember, this top part was neutral. The acidic and basic parts were down at the bottom. So this is neutral. And is it hydrophobic or hydrophilic? Well, it is. Anything that is polar is hydrophilic. It loves water because water also is polar. So this will be hydrophilic. All right, glutamic acid. Look for glutamic acid here, and you'll notice that's at the bottom left of this table, glutamic acid. Now first, is that polar or nonpolar? Well, that's in the polar section. Remember, everything from there on down is polar. So the middle down is polar, so this is polar. If it's polar, we have to say whether it's neutral, acidic, or basic. So we can see here that this is in the acidic section, right? That separates the acidic and basic. So this is an acidic amino acid. And last but not least, we have to say whether it's hydrophobic or hydrophilic. Any of these R groups that are polar are like water, so they'll love water. They're hydrophilic. All right, last but not least, PHE. That's a 3-letter abbreviation, so we're looking for PHE, and you would see that is right here. That is phenylalanine. Phenylalanine. You can see the PHE right there. So the first thing we notice is that it is nonpolar. If it's nonpolar, then we don't have to say whether it's neutral, acidic, or basic. We'd go to the third step and ask, is it hydrophobic or hydrophilic? We can see that on the table. It is hydrophobic. It's nonpolar, it's not like water, it won't mix with it, and so it'll be afraid of it, hydrophobic. So that is classifying those amino acids.